Hi everyone. I'm going to show in this tutorial how to use Stable Diffusion for architecture production, and I have prepared a three-step process. So we're going to look quickly about how to use this type of AI-influenced workflow for parametric design purposes. I will first show you what I set up in my Rhino environment as kind of a textured surface. So you can think about this as, let's say we're making a collage of a building facade. And I have generated kind of an elevation drawing with two buildings adjacent to our facade. And there's just a simple building surface here. So you can make this as much detailed as you want. And what I'm doing is I'm actually looking at this in a frontal view, like in an elevation view. Then in Grasshopper, I've set up something like this. So I've start with the surface and divide the surface into tiles. So I'm using isotrim to do this, and you can control the amount of panels, divisions, number of floors if you want. So I'm going to keep the number at 8 and let's say 14 for now. And I evaluate a point along the surface, and this point is then used as an attractor to actually parametrically control the apertures. So you can move this point around the facade like this. You can also have a different type of attractor input, but let's keep it closer to the ground floor, and I'm going to keep this as an input. The next step is basically getting the borders of these tiles and looking at their centers here and calculating the distance of these centers to our point attractor, which is located here. So if these panels are closer to the attractor, then we will basically shrink the boundary by 80%, right? So these are the coefficients of how much we want to shrink these apertures. So it's basically a simple attractor-based parametric facade aperture. And then I scale these pieces down and render a simple surface there and give it some material, and that material can have any type of display color. So we can make it custom preview. Actually, let's make it a color swatch here. And I'm going to put a red. So this red is going to be basically our facade, right? So this is the kind of collage that I want to generate with the AI. And when you generate a code base like this, then you can actually create a lot of variation, right? You can control the apertures. You can add more panels if you want, so we can increase the panel count. But keep in mind the Stable Diffusion algorithm by default runs on 512 pixels. So the more panels you have, the less rigor it might have. So you have to keep that in mind. So you may not have as much variation or as much detailing if you have a lot of panels and less resolution per panel. So I'm going to keep it like this, and after you have generated an input, let's say visual input like this, then the next step would be to export this as a view so that we can directly input it to the Stable Diffusion algorithm. So in the next step, I will basically create a new structure here. So I'm going to, let's say this was an earlier example I did, but I'm going to create a new folder here and call it facade. And I'm going to come in here and choose the save file path as a selected directory and choose facade. And you have to set up the viewport, but also look at the kind of generated results. So 512 pixels, and I want to save it as a name. Let's call it IMG, or you can come up with another type of name. So I'm going to hit export drawing, and the image is actually exported here. So this is going to be our input, and you can see the facade is actually occupying not as much of an area as the facade. So I'm just going to kind of centralize this in my viewport. We could also draw a border boundary to kind of fix it, but I'm trying to keep this as simple as possible. And then export it again. It should overwrite the facade. So let's see. Sometimes it takes a while to overwrite, but this is basically going to be our input, right? So we have generated an input image that we're going to feed into Stable Diffusion, and you may want this black area to be actually at the bottom of your image. So maybe we move this up a bit more. So you try to centralize the facade drawing a bit. Yeah, this would work. So let's keep this as our input. And once you generated that image, we're going to switch here. And what you need to do is first you need to switch to our model Kenny, because the input image is better processed with these models, and Kenny actually does a good job of differentiating between the pixel values, the colors, and it will be able to give us a better facade generation. And I'm just going to show here what's going to happen in our server. So once I click on the switch model, it will load our pipeline commands and upload a model. Now the model is ready, and I'm going to come in here and choose the input image. So I'm going to select an existing file, go back to the facade folder and choose the image, and it will be displayed here. And our resolutions are 512 by 512. I'm going to play around with these inference values, guidance values. So let's keep this as low in the beginning and strength as 0.5. And we don't have any negative prompts, but I want a parametric facade, elevation drawing, building, blue sky, realistic render, panels, glass panels. I wrote twice, so let's delete this. So you can engineer your prompt. And once I press this, it will send a request to our server, and it will generate an output, and you will get a result, right? So this is the result that I got from our image, input image. So using this workflow now, we can do a lot of things, right? We can control the amount of panels. So let's actually add more panels to this. I'm going to increase the panel count. I'm going to change the attractor position, and I'm going to come in here. So you have to repeat these processes. So you have to export the drawing again. So it will be placed here. Now it's updated, and I can again press the engine. It will send another request, and we will get a different result. So it's not reading it like a flat drawing yet, so it's generating actually a kind of pavement for this black area, but you can create any type of patch and have it as an input using this model. So let's increase our inference value and run this again, and I'm going to generate a few more results. You can see at each time it's actually overriding the properties, and there is no direct influence for this input, so you will have to actually repeat these processes 1, 2, 3. You can also try different colors. Let's actually try, for instance, to make this black so it blends with the ground. I'm curious what's going to happen. So we generate as an input. This is updated, so now the black is actually merging with the ground. So let's see what we get. And the nice thing about this workflow is you will basically store, the code will store all the images that you generate into a separate folder. So it will visualize you the recent generation, but you would also have basically all the outputs archived as well. So let's generate another one. Well, it kind of gave me another interesting result. You can see that the the parametric variability of the facade is actually pretty accurate. So you can generate like larger apertures here and smaller apertures here. But the more panels you have, the less pixel values you can override, right? So it doesn't actually give you too much resolution at this resolution. But you can actually create interesting workflows and try out this tool with different types of inputs in Rhino. So we will do more examples like this. If you're interested in working with Stable Diffusion, you can follow this channel and content, and I'll see you in another video. Thank you.